welcome to our channel of Sciences and Mathematics. I'm Ernest. Today we're going to look at one of the complementary discussions that we had already said or talked about in one of our videos, and that is the concept of nuclear fusion. And this is going to assist us together with the concept of nuclear fission and binding energy to understand how these basic processes work, and maybe try to see how they are being exploited in our current society and to try to provide solutions to our immediate challenges. So in this case, we're going to use the illustration that I've given on board. So first, I'd like to thank and welcome our new members. So kindly, let's keep on interacting in the comment section so that we can be able to assist one another in trying to see different perspectives of these discussions that we're having, and maybe try to raise some of the issues that can assist us in trying to understand deeper some of these concepts that we're discussing. So without further ado, thank you and welcome. So as I've said, today we're going to look at one of the concepts that is nuclear fusion. And nuclear fusion, from that specific term, basically implies the process of fusing two nuclei to form a larger nucleus in the process that is referred to as nuclear fusion. So I've given one of the illustrations on the board that we're going to use in form of maybe this diagram and an equation that involve the interaction between deuterium and tritium, which are forming helium nucleus, and then there's a release of a neutron in that specific order. So in this case, the process of nuclear fusion, as we have defined it, involves the interaction of two lighter nuclei to form a larger one. And this case, from the loss of conservation of energy or mass, maybe we're going to find some kind of deviations, and that is the topic that we're going to handle in details when we're going to discuss about the relationship between the mass defect and the Einstein's energy mass relationship, which we have of course mentioned in one of our videos. So the relationship between the two is going to assist us try to discuss one of the unique cases that we're going to see in the process of nuclear fusion. Now this basically entails the process of joining of the two lighter nuclei, as we have said. And this is the basic process that happens inside the sun of our solar system, whereby we are going to see that the lighter nuclei of specific elements is going to join together under very high temperature and of course pressure. And this process has not basically been exploited to a large extent in our basic applications in our day-to-day life, because it basically involves a very high temperature and pressure in order to overcome the repulsive forces of the protons. I talked about when I was talking about the concept of binding energy. I'll put an illustration, of course, the description, our link in the description box for that specific video, where I was talking about the concept of protons, the neutrons, and the binding energy that is involved. I said that the binding, the higher the binding energy, the more stable an atom. So in this case, I'm trying to split that, or maybe trying to form another bond from that is going to involve very high energy. Basically, a very high temperature and then pressure, which are too great to be achieved practically. So in this case, this process happens inside the sun of our solar system, as I've said. And we're going to see that this process of nuclear fusion, unlike the earlier ones that we had discussed, whereby the neutron was trying to bombard one of the atoms that we had given, this one entails the fusion of two and then the release of energy. Now this is the example that I've given basically, and we're going to see that the concept of nuclear fusion, as we have seen it in a nutshell, is not too much expanded. Now, because we are going to discuss about the other relationship of the mass defect and others that I've already talked about, now basically this is going to be just entail the introduction of this and explaining this specific concept from this illustration, and therefore it's going to give the difference between the other two that we have discussed. So in this case, we're having the vision of this specific nuclear that entails the similar nucleus for this one, and therefore they are going to form this specific intermediate product, which is going to disintegrate to give a neutron, just like in that case, and form this specific nucleus that is of helium containing of 2 protons and then 1 neutron. So in this case, this process is accompanied by the release of energy, just like the other one that we had discussed that was entailing the concept of nuclear fission. Now I hope that when we're going to discuss the the concept of trying to quantify some of the energy that is involved in this case, now using the instance relationship and the mass defect etc, that's how we're going to see how this difference can be able to be explained, or the stoichiometry in this specific kind of a process can be able to be explained in a more clearer way. Now basically that's going to form of the basis for our next video in discussing the summary of this and trying to see what are some of the ways in which we can be able to quantify these specific processes. So I hope that we have seen the difference between nuclear fission and fusion, and trying to see the relationship between these. I'll encourage our members to go to the description box and try to find out what other videos I've got to do in order to understand this, or maybe the relationship between these particular videos and others, which are going to give us a clear impression of what basically these 3 concepts of binding energy, nuclear fusion, and nuclear fission entails. So I hope that we're going to just wind up at that particular point, and I'll welcome us to check out on our next video. So that is it for today, guys. I hope that is going to assist us trying to figure out what we have already discussed. So bye. God bless.